Hello, I'm Stefan Greber, I'm certified LXD, and this is gonna be the last video in our series around LXD devices. I didn't pick the easiest for last. That's the only thing that's left at this point are network devices or NIC. That's probably the most complex device that we have in LXD, but I'm also not gonna go and show every single little tiny detail of it because we have videos that cover a lot of the different options already. So just gonna go through a bit of an overview of what's there, show a few things, but it's not gonna be a comprehensive look at that particular device. So looking at the documentation is also one of the longest page of documentations that we have because of all the options you can have on there. And we can start by the first paragraph here and just kind of explain what's going on. In LXD, when you look at a NIC device, you have kind of two choices. One is to just attach it directly to something that you already have or have already configured in some way. That's usually what you do through the NIC type option on the NIC. So you can set things like NIC type bridged or SIOV, physical, MAC VLAN, you name it. We've got a lot of different options. You can do that without LXD having any idea what you're actually connecting to. So you just set the NIC type, then set a parent key to point to whatever you want to attach to, and that's it. LXD will just locate that parent device and then do whatever is needed to attach it to your container or VM. The other option, which is what we tend to recommend these days whenever possible, is to use the network key instead. With that one, instead of pointing to the name of an interface on the system, you're instead pointing to the name of a network as LXD manages that. So that must be a managed network that shows up in LXD network list with the managed key set to yes. And when that happens, then LXD has a more central way to store settings and to know what you're dealing with. It being a managed device doesn't mean it's necessarily a bridge. We do support managed physical devices, MAC VLAN, oven bridges, normal bridges, a bunch of different options there. So you can still use the network key with that. The other benefit of using that key is that it will play nicely with project limits. You can actually restrict a project to a number of networks, but those must be managed networks by LXD. So you can't, if you're dealing with persistent projects, effectively need to use this. Otherwise, you will need to allow the user to connect to any network, which would be a bad thing from a security standpoint. Now, going over what are the different types of NICs that are supported. As I said, we've got quite a few. The most common one would be bridged. So just connecting to a normal bridge network. That's effectively what you get by default with the managed LXD network bridge. So it's connected through that network key, but internally it's effectively using a bridged device. Then you've got MAC VLAN, which is the easy way to connect to a physical NIC you already have. It does come with the major restriction that host to instance communication will not be possible. Instance to the outside world, no problem. Instance to instance, no problem, but you cannot communicate with your host. So that can really cause some issues and you need to keep that in mind. Then you've got SIOV, where you effectively point at a physical NIC that supports SIOV, and LXD will create a new SIOV slice on that NIC and pass that into the instance. Also pretty simple. But you do need to have the right firmware configuration in place. Physical means you just steal the entire interface effectively. So you point that at a host network interface that you want. And when you launch the instance, it will vanish from the host system and be passed into the instance. Then we've got oven, but oven is a bit special. It can only be used as part of a network type setup. So effectively, you never use NIC type oven really. You usually just use network key to point at a network that happens to be an oven network. And then we've got another few ones that are probably a bit less used. One is IP VLAN. So that's a bit of a special one. It lets you, it's similar to MAC VLAN, but at a higher level. It effectively requires having a specific IP address pre-configured. It gets you another IP on the same, on an existing device effectively. So using the same MAC address for that, which can cause some difficulties in some cases, but can also be very convenient in some situations. I believe IP VLAN will work properly on Wi-Fi, whereas MAC VLAN just can't do that at all, because you can't do multiple MAC addresses on the same NIC on Wi-Fi. So that's one option. Peer-to-peer is interesting for very specific setups where you want to do your own thing effectively. It will get you a simple pair of network interfaces. One end goes into the instance, the other end shows up on the host, and nothing happens with that's on that side. So out of the box, nothing will work, but you need to either bridge or put some kind of network service on the host side interface to then connect to it. Again, not useful for most people, but if you need to do something custom, or if you need to deal with some other kind of odd network setup that LXD can't handle on its own, then you might use that and then do some manual steps to make it work. Rooted is kind of interesting. It effectively uses a peer-to-peer device, but then LXD still provides routing over it. That will require static IP addressing inside of the instance, but you'll get to still route in some traffic. And that can be a good option if you need like complete isolation in some situations. That's always an option too. And that's it for the main types, really. Then you've got config tables for every one of the different types. I'm probably not gonna go through every single one of the keys in there because that would take way too long. But maybe we can go through the bridged ones, as that's what most people deal with. So going up to the bridged section, there we go. There are a few config keys that are available. Boot priority is to control inside of a VM whether you want to boot off a network device or a storage device, like a disk device. So you can set a higher priority there. For example, I should go with 10, which then instructs the firmware to boot from network instead of from disk. The host name key is if you need to control the name of the host side device, you can use that. Obviously, you can't use that inside of a profile because otherwise all of your instances will try to use the same name and that won't work. But on a per instance basis, you can try and use that. The other one would be HW adder, so hardware address, and that lets you configure the MAC address. Same thing, don't want to put that inside of a profile because otherwise all the instances will have the same MAC address and that's not gonna go well. But on a per instance basis, that's something you can do. Those two are usually automatically generated by LXD, and then their value is stored as a volatile key, and you can query that through LXC info pretty easily. Then you've got some other config options. IPv4 address is used to set up a static lease on the DHCP server. There's an equivalent key for IPv6 with IPv6 address. IPv4 routes is a number of routes that need to be put in place as far as traffic going into the instance. So if you have like a subnet or national IP or something in the instance you want to route from the host, that's how you do it. Routes external is effectively the same as IPv4 routes. The main difference is that if you have BGP configured on LXD, it will also advertise that route to BGP peers so that the traffic is then routed to the host and into the instance. IPv6 has the same keys. The main thing that's worth mentioning, Tara, is if you use IPv6 as address, you're going to need to turn on stateful DHCPv6 because otherwise IP allocation is done through stateless auto configuration, and in stateless auto configuration, the address is derived from the MAC address and you can't override that. So if you use IPv6 as address, you need to also change to stateful DHCP. Then we've got a few config keys for throughput restrictions, so that lets you limit the ingress and egress of a device, or you can set limits.max to set both ingress and egress. So you can set limits.max to 1 gigabit, and then the instance network device will be limited to as close as possible to 1 gigabit. Network devices can also integrate with MAS, in which case you can indicate that the bridge they're connected to is a bridge that MAS operates DHCP on. Then with LXD configured with a MAS URL and MAS token, you can then provide a MAS subnet on the NIC to tell it to effectively say that we need an address in that subnet to be allocated, and then LXD will go reserve an address in the subnet and then assign it to the instance. The MTU can be bumped, so that's how you control that. If you need to have an MTU that's higher than normal, you do it that way. Obviously, don't try and set that to a value higher than your bridge, or you're gonna have a bad time, as in you're gonna get your packets chopped effectively. If you have a high MTU on the bridge, you need to go lower for an instance. That's how you do it. The name controls the interface name inside of the guest. That only really works with containers. For VMs, it is possible, but you need to have configured an extra option to have the agent rename your network devices on startup. So there's a config key on the instance that lets you do that, but you need to go do that first before the name key does anything useful in virtual machines. Network key, as mentioned before, that's what you use if you're dealing with a LXD managed network. Parent key is what you use if you don't use a managed network. Queue transmission length lets you override the transmit queue length on the NIC. That can be useful for high throughput or low throughput. It effectively lets you decide what matters to you the most, whether it's latency or throughput, and that can be tweaked and is useful in some specific environments. Then we've got some security options. So that comes with things like preventing IPv4 spoofing, IPv6 spoofing, MAC address spoofing, or providing port isolation. That are all options that we have within LXD managed bridges. This is quite useful in a shared environment. So if you want to use a single bridge but have multiple users use that, you don't want to see either take down each other, so that would be the filtering options, or even be able to talk to each other, that would be the port isolation one. You get to use those config keys. LXD also supports dealing with bridges that are VLAN enabled. So that would be not for a managed bridge in LXD, but for an external bridge that already has a bunch of VLANs configured on it. You can set the VLAN key to indicate which one should be your untagged VLAN in the guest. And then VLAN.tagged is a comma-separated list of VLANs on the main bridge that should be passed as tags inside of the guest. And that's it for the bulk of the config keys. A lot of those kind of repeat on the others with some variations here and there. In this case, we can see that when you're using my VLAN, you get to use GVRP if you want to have automated VLAN configuration effectively. So you get to do that. In SIOV mode, there's nothing particularly special there that we've not covered already with bridges. I guess the main thing would be, well, actually that's in the oven one. So in the oven one, again, mostly looks the same as bridged. It does have the exception of supporting acceleration. So something I showed in some recent videos, but with oven, with Open vSwitch and everything configured with the right NIC from the right vendor, the right drivers, everything lined up. So there's quite some requirements. You can turn on acceleration, which will then offload all of the traffic flows straight to your physical hardware. And that's how you get to do like tens of gigabits up to like 100, 200 gigabit networking inside of LXD instances. On the physical side, there's nothing particularly special. It's effectively the same as what MacVLAN has. So it's got the GVRP option for VLAN advertisement. Then we've got IPVLAN, which is going to be pretty similar as well. Because IPVLAN injects root on the host, you get to control some of the options there, effectively what routing table roots must be injected into. Then peer-to-peer, you can configure some routes as well that are configured on the host, but as mentioned, peer-to-peer is mostly meant for advanced use cases where you're going to be doing a lot of configuration outside of LXD. On the rooted front, I don't think there's anything unusual in there. Actually, a couple of things. So network neighbor probing is something that can be done to see whether the IP address that you've configured is already used or not. So that's something that can be configured there. You can also configure if you want an IP address to be set on the host side, and if so, which one. And was there anything else unusual in there? I don't think so. I think the rest is mostly the same. And that's pretty much it for the options. There's a section in there that covers the MAS integration and mentions what needs to be set on the daemon side. So that's if you need to integrate with MAS. And as I said, usually I go through a comprehensive demo, and I will demo a few things, but we're not going to be going through every single type and everything that can be done. That would take far too long, especially when network topics is something that's probably the best covered currently on the YouTube channel. So there's a good chance there's already a video that covers some of those aspects. All right, so what do I have here? First of all, I've got a keyboard that's not behaving, so give me a sec. It's gonna reconnect, hopefully. There we go. All right, so we've got a few things. This is the machine we use for network testing. It has some interesting hardware. Let's put it that way. Let's see, on the network side, oops, grep, network. All right, so it has actually it's missing some stuff in there that I didn't catch with this filter, because we actually have more stuff. There we go. So the main system is using 2 gigabit network cards, nothing too special. I believe they support SR-IOV, but nothing particularly weird. Then we've got a 10 gigabit Intel card that does support SR-IOV. That actually has it enabled right now. That's why we see those 60 something VFs here. There is also a Mellanox dual 40 gigabit card that's probably in InfiniBand mode at this point, so we can't do Ethernet on it. Or maybe it's in half and half. I think it might have one port on Ethernet, one port on InfiniBand. Then we've got a dual 100 gigabit NIC that's also from Mellanox. And we've got a 2.5 gigabit NIC from Realtek. So that's what we use for daily testing of all different kind of network hardware. As far as the config, we have a basic managed bridge configured, LXDBR0. So if I launch an instance here, this is just going to go straight on that bridge, nothing special. And if we look at the config on that instance, we can see, yeah, if 0, LXDBR0, nothing weird at all. Now, if we go in the instance and let's say install iPerf, then I need to get on one of my routers. Okay. And let's see, 250. Yeah. Okay. So we're currently doing about gigabit on there, which is expected. That's a gigabit NIC that's backing the system, so nothing particularly special. Let's just put a quota on that. So U1 if 0 limits.max equals 100 megabit. Try that again. And 100 megabit. Well, the problem with applying those kind of throughput limits is that it effectively requires a bunch of queuing and forcing TCP into retransmits and stuff. So you tend to often get a lower speed than the limit you set. In this case, like doing multi streams will get us closer to the limit, as we can see. And if you do, the longer you transfer, the closer you're going to be to the average limit. But it's something to keep in mind. And often the enforcement is a lot easier in one way than the other. So I suspect if we do a reverse, we should be getting much closer to 100 megabit. Yeah. So that's the limits side of things. It can be applied to a lot of our different NIC types, and that works pretty well. Now let's look at something slightly more exciting. And as you've seen, I did show there's a bit of SR-IOV going on here, and that's all backed by ENP5S0. So let's launch, actually we can use the same instance. So I'm gonna stop U1. Okay, I'm gonna remove its current NIC definition, and we'll add another one back on top. So in this case, let's do SR-IOV, parent is ENP5S0, name is still if0, and start. I'm not putting any limits here because you can't do limits on top of SR-IOV. LXD has no control on the network side on the host. Everything is done through hardware. So now if I go in there. The IP address is no longer the same. As you can see, it's now showing up as an IP address on the external subnets that I have. But I expect things still work just as well. And indeed, we're getting gigabit, no problem. Now, if we want to go and do a full NIC, so I think I've got ENP 13S0 I can use for that. Instead, we're going to do physical and start it. And it's going to, in this case, make, so if we do ENP 13S0, it's gone because it's been moved inside of the instance. It's not up yet, it's up now. There we go. So again, iPerf working just fine. And it will be on the same subnet as the other NIC. Like, this is a test system. It's got, I don't know, 7 network connections or something, but they're all going to the same network effectively. So yeah, that works perfectly fine. And let's stop that. What else can we do? We could do the same thing with MacVLAN. So if I remove that, add it back, and let's use the exact same physical NIC, but let's do MacVLAN on it instead. This should still work fine. It will actually work perfectly fine in this situation, I expect, because the host system doesn't actually use that NIC. So as a result, things should just behave. That being said, it can be a bit finicky sometimes. I might actually have an issue because the host itself doesn't use it. It shows lower layer down, yeah, so that most likely means that ENP 13.0, yep, the host side device is completely down. So let's bring that back up. Okay, it shows up on the host now, which should help in the guest, shows as up. Don't have an IP address back on it yet, but that could be because network D gave up on it already. So let's bounce network D. There we go, got an IP address. So that's now on MacVLAN. Still effectively the same behavior. We still have an IP address in the same subnet and everything. I could show what the problem is with MacVLAN. In this case, I expect I can ping that just fine because I'm not using ENP 13.0 for outside connectivity on the host system. So it's all fine. But if I look at my own system, we can see that I'm using ENP 9.0 here for my host. So now if I go and say remove the NIC and add the NIC back, but this time the parent is ENP 9.0, so on purpose using the same as my host system, and I start that back, the guest should be getting an IP just fine, as we can see. Connectivity should be just fine for the guest too. If we go iPerf, yeah, no problem whatsoever getting gigabit again. But now the catch is, if I try to ping this from the host, this fails. That's despite the guest being absolutely capable of, pinging the gateway. So if it goes ping that works fine. The host can similarly ping the gateway, no problem. But the host and guest cannot communicate. So that is the restriction with MacVLAN, and something to keep in mind because it is very confusing when you don't expect it. What else can I show easily? Could show the routes. That would be one thing that can be done easily enough. So if I remove this, so now we're back to the host networking. Let's put a limit back just for kicks. And let's say I want to route 1, 2, 3, 4 /32 to the guest. And let's see if network D understood what's going on. Yeah, IP address moved back to the bridge, it's fine. And now if we look on the host, I should have a route to 1, 2, 3, 4. That goes through the bridge, that's fine. If I ping 1, 2, 3, 4, that's not gonna work, obviously, because the guest itself doesn't currently make use of it. But if I add it there, it works. So that's the control for IPv4 routes. I'm not going to show external because that would require having BGP in place, which is not really an option. The MTU I could show, but that will just do what you expect effectively. Queue transmit length is not the most interesting. We could show the port isolation, that could be interesting. So let's launch another container. And also the feature I've ever really used myself, so I hope it works as intended. 10.231.229.12. Okay, so I can currently talk between U1 and U2. Now let's try to set the port isolation feature on U1. I don't know if that works live, so we'll see. No, it doesn't seem to. Or maybe both of them must have it set. I'm not sure. Anyway, let's restart U1. Let's make sure the internet still works. Yep. And it can still talk to the other one. Okay. Let's set it on both. Okay, now that seems to be working as expected. So I can still ping my gateway. I can still go to the outside world, but I cannot talk to the other instance. Nor should U2 now be able to talk to 130. Indeed. So that's what you would do if you needed to actually isolate a bunch of containers on the same bridge and couldn't just go and create more bridges effectively. So that's working as expected. The other option that I could do is, actually let's turn that off to just make things a bit simpler. Okay, so if I do that, it will solve fine. And if I now go in U1, I should be able to ping the internet, no problem. Now let's on purpose turn down the interface and then do HWAdder. Actually, let's see what the MAC address is. Okay. HWAdder, and I want this set to 62. Actually, it's address, I think. Yeah. Okay. It is 0, bring it back up. Okay, so we do have connectivity. It picked a different IP address, which is expected because the MAC address changed, but everything just works. But I just spoofed my MAC address. I just changed the MAC address to a value that's, it doesn't match the one in LXD. So that's not good. So let's see what happens if we turn on the MAC filtering feature, which is designed to prevent doing exactly that. So 0 security.mac filtering true. Okay, so now my connectivity is completely gone. So let's bring the interface down again, set the MAC address to the expected value and set it back up. Wait for the address, we're good. It came back with normal IP address and I can ping just fine. Now, say I want to remove the current IP address. Actually, I don't know if replace exists on this one. It does on some command. The help for this stuff is always a mess. No, replace does not. Actually, it does exist. If other dev if name. Okay, let's see. Okay, so that works. Let's see. So I can still ping to the outside world. Now, if I go and I want IP 200, that still works. It did not remove the old one, so let me go fix that, because otherwise the test is not super useful. Address there. Okay, so now I only have one IP address, which is the 200 address. I lost my default gateway as part of that. Fun. 239.229.1. Okay, so now I've effectively spoofed an IP address because that's not the IP address that I'm supposed to be having in that instance, but it still worked. So let's go and block that too. So IPv4 filtering true, and still make sure we're on the wrong address, and that doesn't work anymore. Now if I replace that with the IP address I'm actually supposed to have, which is 130, and then I remove the one I'm not supposed to have, which is 200, and then I add a default gateway again because it will probably have been removed. No, it's still there. Cool. Now it works again. So that's the IPv4 spoofing. I could do the exact same exercise exercise again with IPv6, but I guess you get the point. So that's how that works. Is there anything else that I could cover easily? I don't really think so. And I think that was a decent overview of bridge networking, physical networking, MAC VLAN, and SRIOV, as well as some of the options that you can use on top of that. As mentioned, this is probably our most complicated device type by quite a long shot. So look at the documentation. It should be pretty detailed and clear at this point because we've had that for so long. There are also specific videos on a lot of the different topics. Like if you want to do oven, there's a lot more things to think about than just the NIC. There's the actual network setup and all that kind of stuff. Same goes with the acceleration topic, for example. Same goes with a lot of the other network features, whether it's like routing IP addresses in, doing BGP, doing that kind of stuff. And we have pretty good videos on a lot of those topics already. If we've missed anything, if you'd like something in specific to be covered, just leave a suggestion down in the comment section below and we'll look into doing that. Otherwise, there's the link to the documentation below. There is the link to the community forum where you can also go and ask questions. So thanks for watching. This was the last video in this roundup of LXD devices, until we find some other device types to add to the mix. I hope this was useful. Hope you liked it, and I'll see you in the next video. Bye.